In this video, I'd like to talk about the math question of the day for Friday, August 4th, 2023. And with this problem, we need to find the sine of twice this angle, ABC. And questions like these are typically seen either in a pre-calculus class or a trigonometry class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start going through this. And there are a couple different approaches we can take. One approach is that we can figure out the measure of this angle and then double it and plug it into our sine function. And to do that, we just need to use basic trigonometry. We can write down our right triangle definitions for the trig functions. And we need to figure out this missing angle here. This is angle ABC. And we can do that using any of these definitions since we have all three side lengths. So let's use the tangent. Though, like I said, you can use sine or cosine if you want. The tangent of an angle is equal to the ratio of the opposite side to the adjacent side. So if we want the tangent of angle ABC, we're looking at the ratio of the side opposite to that, which is side length 8, divided by the side adjacent to it, which is length 6. So we get the tangent of angle ABC is 8 over 6. And if we want, we can then find the angle ABC by taking an inverse tangent of each side. We get the inverse tangent of 8 over 6. Which, if we plug this into our calculator and we make sure our mode is in degree mode, we get 53.13 degrees approximately. And just so you know, it is an irrational number, so the calculator has to round it at some point, but usually its decimal expansion will go on forever. And now that we have this angle, we can just double that and plug it into our sine function. So we have the sine of twice this angle, which is approximately 53.13 degrees. And when we use our calculator, we plug this in to get the decimal of 0.96, which is 24 over 25. So either of these answers here should be fine. And this is one approach that we can take, but there is another approach that might be a little bit cleaner, and that is using the double angle formula, or we can call it the double angle identity. So let me quickly paste that in. And this formula just states that if we have the sine of twice the angle, that this is equal to twice the sine of the angle multiplied by the cosine of the angle. And we want twice this angle ABC, meaning that in our case, the angle theta that we're looking at is this angle ABC. So when we want to find the sine of twice theta, or twice angle ABC, we're looking at twice the sine of our angle, the sine of theta multiplied by the cosine of theta here, since we're calling this angle right here theta. Now, the sine function will need our trig definitions again, so katoa. The sine function is the opposite over the hypotenuse. So we're looking at the ratio of the opposite side, which is 8, and we'll divide that by the hypotenuse, which is 10. So that's for the sine function. The cosine is the ratio of the adjacent, which is 6, to the hypotenuse, which is 10. So the cosine of theta would be 6 over 10, and now we just simplify everything. Notice that we have 2 times 8, which is 16, times by 6, which would be 96, and 10 times by 10 would be 100. So we have 96 hundredths, or 0.96, but if we simplify that fraction, we get 24 25ths. Now, both of those approaches are valid. They both ended up with the exact same solution, so either of those can be used for problems like these.